Hi everyone, in this video we're going to talk about 2.5 postulates. So what is a postulate? We've been talking about properties, algebraic properties like distributive property, addition property, multiplication property in the last video of algebraic proofs. We talk about theorems like Pythagorean theorem, which is a squared plus b squared equals c squared. And now we're talking about postulates. So postulates are like axioms. There are statements that are also true, that are really more focused on a geometric aspect of things. The algebraic proofs video, we spoke about adding and subtracting and multiplying properties, distributive property. Those are all dealing with real numbers. But with postulates, we're dealing with geometric properties that are also assumed to be true. So let's get right to it. Here's a list of some postulates. Now there's a lot more postulates where this came from, but here is a list of a few postulates. Right? Postulate 2.1 is through any 2 points, there's exactly one line. And there's an image here on the side to describe what this postulate looks like. Now, if you look at these postulates, some of these look very similar, right? They look very similar to each other and can be hard to distinguish which one of these postulates is being used. But all of these postulates are true. They're 100% correct. So if you see a postulate, you can assume that this is always going to be a true statement. You can pause this video, read through some of these. We have these notes in class that you can use on your test. Pause it, check it out, and we can move forward. So how do you think about a postulate? Here I'm putting two examples, postulate 2.1 and postulate 2.3. As an example, because these two postulates sound very similar. Just like 2.2 and 2.4 sound very similar. Right? If you look at these two, they're both dealing with points and lines. What is the difference? Well, it's based on the premise. What am I given and what am I allowed to conclude? So when I'm trying to understand a postulate or a statement to see whether it's true, right, I want to convert this into an if and then statement. So if I write the first postulate as an if and then statement, I would say this. If I have 2 points, then there exists a line. Right? And what this really just says is that if I have 2 points, I can construct a line through any 2 points. So if I have points A and B, I can construct a line through them. Postulate 2.3 is the converse. A line contains at least 2 points. So here, if I write this in if and then statement, I'm really saying is if I have a line, then there are at least 2 points. Take a second to think about that, right? Because there is a difference. The one in blue, postulate 2.1, I'm saying if I have 2 points, so I'm given, right, 2.1 gives you 2 points, A and B. If you're given 2 points, then you can construct a line. And in the meantime, right, meanwhile, 2.3 says the converse of that statement. If I have a line, then there's at least 2 points. So you start with two different premises, two different hypotheses, and you conclude different things from it. Okay, so this is where thinking about if and then statements really kicks in, and this is our last topic of this unit. Right? So understanding postulates requires you to have sound logic that we've been developing throughout this last several weeks. So how do you think about a statement whether it's always, sometimes, or never true? Right? Is something true, sometimes true, or never true? The way to do it is write it as an if and then statement. So first, change it to if and then. Convert the statement to if and then draw a picture. Now, if you cannot draw a picture of the given statement, by default, never true. because it's not even possible to do it, right? So if you can't draw a picture, it's a never true statement. Now, if you can draw it, then by default, it's going to be always or sometimes. If the statement you have, and we'll go over several here in a second, if the statement you have is possible, then for sure it's not never. It's not this possibility. So then we have the possibility of it being always true or sometimes true. Now, as you draw your picture of the given statement that you'll see in a little bit, the picture is true the way you wrote it or the way you drew it. Can you draw an alternative example, a counterexample that would make it not true? Draw an alternative example that follows the statement, and if you can have multiple representations of what you're saying, then it's going to be a sometimes true situation. Because sometimes this works and sometimes it doesn't work. Okay? So let's get through some examples and see if we can dig into this thought process a little bit. Always, sometimes, and never. So, we have 3 collinear points determine exactly one plane. 3 collinear points determine exactly one plane. Change it to if and then. So, my statement is, if I have 3 collinear points, excuse my handwriting, then we have one plane. Okay, so the first thing is understanding it. What am I given? What can I conclude from this statement? Okay, if you write it in if and then form, it'll be easier to break down and visually see what you're happening. So if we have 3 collinear points, let's draw 3 collinear points. 3 collinear points means that we have 3 points that are on the same line. Now, this statement right here, this picture, can I conclude from here that I have one plane? No, I cannot. This is a never true situation. A line never determines a plane. A plane is 2-dimensional. It's got length and width. It's got horizontal distance and vertical distance, right? It's got to go in 2 dimensions, and a line is 1-dimensional. It only goes in one direction. So if you have points on a line, that does not mean that you have points also on a plane, okay? Because then it's only 1-dimensional versus 2-dimensional. Now, if you did have it backwards, where they were on a plane, then you could say that they could be on a line, right? So this is why it's important to break this down and think of it as if then. If I have 3 points on a line, does that mean that I always will have a plane? No. This is false. Here we have 2 points, A and B, determine exactly one line. Let's write this out as an if and then statement. So if I have 2 points, we'll say A and B. Then I have one line. If I have 2 points, then I have one line. What does that sound like? If you look at the postulates that we were looking at before, right? That is postulates 2.1. This is verbatim postulate 2.1. So since I'm using postulate 2.1 as my given statement, this is always going to be true. Postulates are always true. They're never sometimes. If you have 2 points, A and B, then you can construct a line. Always true. All right, let's look at this example. The intersection of 2 planes contains at least 2 points. Go ahead and look at your postulate sheet and look at the last one. Postulate 2.7. let's write this an if and then statement, okay? If I have two planes intersecting, if two planes intersect, then they intersect at least 2 points. Ugh. Right? If two planes intersect, then they intersect at least 2 points. So let's draw a picture. If you look at postulate 2.7, there's a nice picture there, right? I'm going to try to draw it myself. So I have a plane here, I have a plane over here, and they're intersecting here in the middle. Right? I don't know if you guys can see that well. Let's see if I can draw this a little better. Here in the middle, I have a plane intersecting. I'll change the color where they intersect. So I have two planes, they intersect right here in the middle. Now, if two planes intersect at a line, then what do we know about a line? A line contains at least 2 points. So we know for sure that if they intersect and they intersect at a line, then the intersection will include at least 2 points. That's what this one says. If two planes intersect, then they intersect at least 2 points. For sure. Because they intersect at a line. This is always true. Let's check out our last example. Here I have a statement that says if points G and H are contained in plane M, then GH is perpendicular to plane M. This one's already an if and then, right? Now we just have to determine the validity. Is this always true, sometimes true, or never true? So if 2 points G and H are contained in plane M, so let's draw a plane. I have 2 points in here, point G and point H. Then GH is perpendicular. GH is going to be a line. GH is perpendicular to plane M. Now this means perpendicular means that they intersect at 90 degrees. If I have a line that goes through GH, will this line be perpendicular to plane M? Never true. A way to think about it is this. There's a flat surface that has 2 points. Will the line that goes through those 2 points intersect the plane or the flat surface at 90 degrees? No. You cannot have a line go through here at 90 degrees so that G and H, you can't have a line that has G and H that goes through it and at the same time have G and H both on the flat surface, right? Something's going to not be on the surface. G or H is not going to be on the surface. It's going to be either on top of the paper or below the paper for it to intersect at 90 degrees. So this is a never true statement. You cannot have 2 points on a flat surface and then at the same time say, well, one of them has to be perpendicular. It's going to be outside of it. This is a never true statement because it contradicts it. The points have to be on the flat surface. They can't leave. So let's review a little bit. You want to convert your statement to if and then draw a picture. If you can draw the picture, right, then it's going to be always or sometimes. If you cannot, like the previous example, I can't draw a picture where G and H are on the plane and it's also perpendicular to the plane. I can't draw it. This is a never statement, right? Now, if you don't have a never statement, let's say you have an always or sometimes, that's when you have to determine different situations like, can I draw a picture alternative to this one that does work or one that doesn't work so that I can make it a sometimes statement. And that's how you determine whether you have an always, sometimes, or never. I hope this has helped. I know this topic can be very confusing because you're trying to think about it, you're trying to reason through it in your head of how things make sense. But the easiest way to go about this topic is to convert it to if and then. And that is the conclusion that you can form. If this is true, then this must be true. It's very easy to start thinking if then if, and then you start switching the ifs and the thens and going backwards and focus on the direction. What am I given? What can I conclude? And then analyze that statement by drawing a picture to see if it's possible, right? If it's not, it's a never true scenario. All right, guys, hope you guys have a good one. Good luck studying for your test. Don't forget to like and subscribe, and as always, we'll calculate later.